So this is sort of quick review of what was done on Wednesday. So the first thing we did was we defined radians, right? Like if somebody says you have an angle and it is, I don't know, like z radians. The angle is z radians. What does that mean? What angle is that? What angle is that? Okay. And the answer is that the radians basically tells you, you go to the unit circle. Okay, so I'm not going to go into this in a lot of detail because we should have done it on Wednesday. But you go to the unit circle, so go to the unit circle, and you start from here, and you measure off z, so distance z. Okay, so let's say that let's say that this length is z. Okay, let's say that this length is z. So let's call okay. And then the angle, which is z radians, is this angle here. Okay, so this angle is z radians. And this is basically how you define the radians. Okay? Everyone see that? Okay, I know you're back. This is sort of a quick jump in, but we gotta jump in. Okay, this is already done. Okay. So if somebody tells you an angle is z radians, then what angle is that? You go to the unit circle. It has to be the unit circle. Otherwise, you're going to get the wrong angle. You go to the unit circle, and you start from here, and you go in this direction, and you measure off z, an arc of length z, and that the angle that corresponds to that arc is the angle that we call z radians. Okay. So, for example, if somebody says, what angle is pi radians? What angle is pi radians? Well, then you go to the unit circle. You go to the unit circle, and you say, okay, well, when do I reach an arc length of pi? When do I reach an arc length of pi? Well, the full circle, what's the circumference of the full circle? Right, circumference of the full circle is 2 pi, right? The circumference of the full circle is 2 pi. So when do you get to pi? Well, when you get to here, right? When you get to this point. And so this angle is the angle that we call pi radians. This angle is what we call pi radians. Okay. And if somebody said what angle is 2 pi radians, well, that would be the full circle, the angle corresponding to 360 degrees in the degrees measurement. Okay, right. If somebody said what angle corresponds to pi over 4 radians, well, what is that? Pi over 4, well, if this is pi, then this is pi over 2. This angle is pi over 2, right? And this angle, after that, 45 degrees is pi over 4, right? So this is pi over 2 radians. This would be pi radians. This would be 3 pi over 2 radians. This would be 2 pi radians. And then they keep on going around, actually. Keep on getting bigger and bigger. So, does that make sense? I think most of you have probably seen radians before. Okay, so another quick review. How we define the tree functions. What is cosine of theta? So theta is in radians. What is cosine of theta? What is sine of theta? Okay, and here's how we define those. And it's a little bit different. If you've seen it only with triangles, it's a little bit different, so please pay attention. So what you do is, again, you go to the unit circle, or it could be any circle, I guess. It could be any circle. You go to theta degrees. You go to theta degrees, whatever that is. I'm sorry, theta radians. Theta radians. And then the cosine is the x-coordinate of this point. The sine is the y-coordinate of this point. Okay? The cosine, so you make an angle of theta radians, you intersect it with the circle, with the unit circle. It must be the unit circle, sorry. It must be the unit circle. What was I saying? That was crazy. Because if we did it on a bigger circle, we're going to get different numbers, right? That would mean that the cosine depends on what circle. The cosine shouldn't be something that changes, right? So you go to the unit circle. I guess I need to wait for myself. You go to the unit circle and you draw an angle of theta radians. You intersect it and you look at the cosine is the x-coordinate, and the y-coordinate is, we call it sine. Okay. So for example, if somebody says, what is cosine of pi over 2? No, that's it, yeah, cosine of pi over 2. Well, you come to the unit circle and you say, okay, I want the angle pi over 2, and I want the x-coordinate of that. Well, the x-coordinate is 0, right? So cosine pi over 2 is 0, sine pi over 2 is 1, right? Sine pi over 2 is 1 because it's the y-coordinate. It's the y-coordinate. Okay. Yeah, that,
What's tangent?
tangent is, of course, just sine of the cosine.
So there isn't one?
So that's right. For this one, the tangent is undefined.
Oh.
Yeah. So tan pi over 2 actually is not. Okay. So let me ask you, just to make sure you get this definition, for what angles is cosine negative? For what angles is cosine negative? Okay, just take 1 minute, write down something. And also for the sine.
In degrees or radians?
It has to, in radians actually.
Right.
It doesn't have to be, but basically in this class, everything will be in radians.
Okay. Okay, who would like to try? Who would like to try? Sorry.
Okay, so the way I thought of it was
Yeah.
because you said cosine is negative, do you mean to say all the x values which are negative?
That's right. It would be the angles which give you points whose x values
That
are
was
negative.
negative. So
Yeah.
it would be all the angles after and between 90 degrees.
Between pi and 2, yes.
Yeah, and 270.
Between and 3 pi.
Or, yeah, is that right?
Yeah, well, basically, so certainly, right, so over here, when the angle is before pi over 2, all the cosines are all the x coordinates, and thus all the cosines are positive, right? So cosine is positive here, cosine theta is positive, right? Positive here. It's also positive here, right? Right, so for like negative angles, for negative between 0 and negative pi over 2, it's positive, right? And then once you cross this line, once you pass pi over 2, then cosine becomes negative, right? And it stays negative until you pass 3 pi over 2, and then it becomes positive again. Right? Do you guys see that? Right. So, right, it becomes positive again, and then at 2 pi, the cosine is 1, right? At 2 pi, the cosine is 1, and then it becomes 0, and then it becomes negative again, and then it becomes positive, and then it becomes 0, and it becomes 1, 0, like this. Right? You guys see that? Okay. Right? So if we were drawing the graph of it, if we were drawing a graph of it, we'd say, oh look, between 0 and, let's say, so here's pi over 2, here's pi, here is 3 pi over 2, here's 2 pi, 5 pi over 2, etc. But let's say that this is 1 and this is negative 1, right? At time 0, the cosine is 1. At time pi over 2, the cosine is 0, right? It becomes 0, so it drops down here. And then it becomes negative 1 here. At time pi, it becomes negative 1, right? And then at 3 pi over 2, it becomes 0 again, right? And it goes up and goes down again, right? And up and down. Up and down again. Like this. Right? So the cosine, this is how the cosine behaves. Right? Alice, you don't talk. What's wrong?
No.
You thinking?
Yeah.
Okay. Okay. So, right. So this tells you that, for example, you have an angle here, then the cosine is positive. You have an angle here, the cosine is negative. The angle here is cosine is negative. The angle here, the cosine is positive. Right? Which, when I was a kid, we had to memorize. You had to say, oh, you memorized some pattern, right? With the triangles. But I think, thinking of this in terms of the x coordinates and y coordinates, it's easier. Right? It's obvious. Cosine is the x coordinate. It's negative here, it's positive there. Right? Sine is the y coordinate, so it's positive here and negative here. Yeah. Okay, so so let me ask you a question. What's the cosine of 1 radian? Or is the cosine of 1 radian positive or negative? Cosine of 1 radian.
Negative.
1 is the number 1.
Oh.
Not 1 pi radian, just 1 radian.
It's positive, except it's 1 degree.
No, it's not the same as 1 degree. Who knows the answer?
What's the radian of that?
Yeah, what's a radian?
Is it a 1 radian to 180 degrees? No, yes. No.
Pi radians is
Oh,
180
pi.
degrees, right? So let's, again, okay, so, right, this is, so here's the unit circle, right? What does 1 radian mean? 1 radian means that we measure off a distance of 1 along this arc, right? And then we want to see if the cosine is positive or negative. Okay, well, how long is 1? If the full circle, let's see, this is a unit circle, so what's the length of the full thing? You know it's 2 pi, right? So the full circle is 2 pi, that's about 6. It's about 6, right? So this is about 3 radians, right? It's actually 3.14159, blah, 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 right? Okay, so where's the 1? What's 1 radian? This is 3. This guy's 3 radians. Where's the 1 radian? It's somewhere over here, right? I probably can't draw it having no distance. Hey, that was good. Okay. So, right, 1 radian is about here, and so you see that the cosine of that is positive. Okay. Just to get the idea of what a radian is in your head. Okay. Okay. But it's actually not so easy to tell what the cosine of 1 radian is, right? How do we tell what the cosine? We have to make the circle, we have to measure off exactly 1, and then we have to drop down here, and then measure this distance. And that would just give us some rough approximation of what cosine of 1 is, right? What cosine of 1 is. That's not so easy. So not easy calculating. So notice that calculating cosines and sines, not so easy. Not so easy. One actually has to do, you have to do some sort of approximation. And this is what, remember I mentioned earlier, you can actually build a Lego computer that will do this for you. And that one of the first applications of the early computers the so-called difference machine of Babbage, right? One application was to calculate sines and cosines. Okay, so the moral is it's not easy to calculate calculate cosines and sines, but except for some angles. Okay, for some angles it's actually pretty easy. So for example, angles. Angles, which is, I'll just write easy angles. Easy angles. So the first one, is pi over 4. Pi over 4. Somebody says, what's the cosine and sine of pi over 4? Cosine and sine of pi over 4 radians. And what would you tell that person? How would you, if somebody asked you to figure it out, how would you figure it out? Julian, how would you?
I memorize.
You memorize it, yeah, but you've suddenly forgotten. Okay, you've suddenly forgotten, or like somebody says, I don't believe you, right? You have to explain to me why it is what is it? Do you remember what it is?
I forgot what the original got.
Okay. So what's pi? Let's figure it out. Suppose we've forgotten everything, like even who we are and what we're doing, except we remember that we've been asked to calculate the cosine and sine. What are the cosine and sine of pi over 4? Okay. So how would you do it? Well, you'd say, okay, well, I know that pi over 4 is halfway between here, right? Pi over 4 is here. Right? If I take this full, 90-degree angle and split it into, so that's the pi over 4 angle, right? Okay. And so the question is, what's the cosine? Right? What's the cosine? Right? So here I have to drop down to here, and this thing is cosine pi over 4. This thing here is sine pi over 4. And somebody's asking you to figure out what those things are. Right? Well, what are those things? Can anyone tell me how you might figure them out? So,
This is like a weird guess, I don't know if it's true, but would it be the half, distance between 0 and 1? Because if you think about it, yeah, I mean.
so you're guessing,
I think it would
you're
be
guessing
half.
it's a half.
Yeah, because, I forgot what to say, like the cos, or the cosine of 90 degrees would be 0.
Cosine is 0, and the
Yeah.
cosine of 1 is
yeah,
1. And so you're thinking, well, maybe it's some sort of midpoint.
Because,
Right.
even 45 degrees is, again, half.
45 degrees is in the middle, so
Yeah.
maybe cosine of 45 degrees is halfway between these 2 points.
Yeah.
That's a good guess. That would work if the cosine function were a linear function. If it were a linear function, then that would be true. Then you have 2 values, and you're measuring at some median value. Well, the middle value here is going to be average of the heights. Okay, so that would work if this thing were a line-like function. It's a good guess. The cosine and sine, as you see, aren't line-like functions. They're sort of they go up and down. They curve. There's some curve to them. So it doesn't work. But it's a good guess. It's a very good guess. Yeah, Kate.
How do you start a number from special triangles?
Triangles. You can use triangles, right? You all have geometry. It's fair to use geometry. So you'd say, okay, well, we drop this down perpendicularly. So this is a 90-degree angle, right? This angle here is pi over 4, right? So what about this angle? Also pi over 4, right? This angle is pi over 4, right? And so, so we have what do you call it? Triangle, right? An isosceles triangle, right? We have an isosceles right triangle, right? So this length right? This length x and this length y are the same, right? And what else do we know about x and y? What else do we know about x and y? What?
Cosine and sine. Also,
The cosine
oh,
sine.
you mean in the special triangle?
In terms of the triangle?
Radical 2?
What?
In terms of triangle?
Yes.
Yeah, radical 2. Because there's special 45, 90.
Okay, sure. Okay, so like you know that this length is 1, right? Because this is on the unit circle, right? And then by say Pythagorean theorem, you know that x squared plus y squared is equal to 1. Actually, they're the same thing, right? X and y are the same, so I'm just going to write x squared plus x squared is equal to 1. So
No, I'm just wondering, we're trying to find the point on the x-axis.
we're trying to find this length here.
Oh,
This length here,
okay.
right? We want to find the x coordinate. Of
I'm sorry,
this.
I thought you were trying to find like the particular point. Wait, okay, never mind. I'm just.
We're trying to find the x and y
Okay.
coordinates of this point.
Okay.
Okay, so x squared plus this length, let's call this length x, let's call this thing, let's call this thing x, let's call this thing y. I mean, we can, maybe instead of saying, wait a minute, I'll just write it like this, cosine of this squared plus cosine of this squared is equal to 1. Right? Right? So what does that tell you? That tells you that cosine of this square is 1/2. Right? We divide both sides by 2. Right? We've got 2 cosine squareds on the left. And then we take the square root. Right? And we get that this is plus or minus the root of 1 over root 2. And it's positive because you look at it and you say, oh, it's positive. Right? Because we're in the first quadrant. Right? Okay. So we know it's the plus sign. Okay. Okay, and what's the sign? What's the sign? Katie? Well, the sign is the y coordinate, right? And we see that in the picture, right? Because this thing is a isosceles triangle, they're the same thing.
Oh yeah, so it would be the same, right?
Yeah, so the sign is also, right? The sign of 45, the sign of pi over 4 is also 1 over root 2, which you can write 2 root of 2, sorry, you can write as root 2 root 2. But I'm just going to do it like that. Whatever it is. Yes?
Is there going to be another step, because when I had to memorize these, and I had a different value that I knew?
You have a different value. What was the other value?
2 over root 2.
It's the same thing. It's the same thing. Right? 1 over root 2, if you multiply by 1,
Got it.
you get root 2 over root 2 squared, which is 2.
Okay. Yeah.
It's the same. Okay, Kate.
What about when cosine and sine are different?
That happens, right? So we're lucky. In this case,
But would it be hard to figure out? You have to do something else? Or?
yeah, that's right.
Okay.
That's right. So we'll do more. So this is the simplest one.
Okay.
This is the simplest one. But figuring out the cosine and sines is not so easy in general. But for some angles, it is easy. Here's maybe the easiest one. Okay, here's the easiest one when the angle is pi over 4. Yeah, go on.
So tangent would just be 1, right?
The tangent would be 1. Yeah, because tangent is sine over cosine. Okay. Anyone confused? Anyone confused? Okay, so now what about some other, what's another angle that's not so bad? Pi over 6 is not so bad. Pi over 6 is not so bad. And I'm sure that you all had to memorize this as well. If you've seen this before. Okay, so again, you have a friend, and the friend says, I don't know trigonometry. Somebody said to me that you can figure out the cosines and sine of pi over 6. How do you do that? How do you do that? Okay, well, look. If you take an angle, and again, I'm probably going to mess this up, but pi over 6. So this angle is roughly pi over 6. Okay. And then I'm going to take another copy of that going the opposite direction. Okay. I'm going to take another angle with pi over 6 going down. Okay. And then I'm going to draw a line from here, dropping down to here. Okay. I'm going to put two of these. I'm going to drop a line down here. Okay. Make a right angle. And I'm going to do the same thing from here, make a right angle. Okay. Those two are just reflections of each other, so the lines are going to meet. Lauren?
Why do we have to do that for this one, not the previous one?
Because the previous one is easy, and this one requires a little bit of trickery. Okay. It won't be, if you try to do it the way we did this one, it won't work.
Really?
Yeah.
Because you know the hypotenuse.
You still know the hypotenuse. You still know the hypotenuse. Right?
And you know the angle.
You know the angles. That's true. Right? This is pi over 3. Right? But then what do you mean?
Oh, they're not the same.
Yeah, they're not the same anymore.
Okay.
What's the relation between these two? It's not so clear. It's not completely obvious. No. Yeah. Okay. So, so here's one way of figuring out the cosines and sines. Right. Remember what we want. We want to figure out. We're trying to figure out. Right. So this is pi over 6 thing. We want to figure out the x coordinate and the y coordinate. X coordinate and y coordinate of these points. Right. Of this point. Okay. So here's what we do. We play something funny. We take two copies of the triangle and stick them together. Okay. So let me ask you this. What's this full angle here? What's this full angle?
60 degrees?
60 degrees. Let's say pi over 3. Pi over 3. Pi over 3. Okay, what about these angles here?
60.
Right, they're also 60, right? They're also 60 degrees because they're the same angle, and this is the sum of angles is 180, right? So if this one took up 60, there's 120 left, and so each of them gets 60 as well. Okay. So what do you notice? It's an equilateral triangle, right? So this guy here is equilateral. Okay. Okay. So what are the sine and cosine?
Sine 1/2.
Sine would be 1/2, right? Because you know that this is length, right? All the sides, it's an equilateral triangle, and all the side lengths are 1, right? So this is a half, right? This is a half of that. So the sine is easy, right? Sine of pi over 6 is a half, right? Okay. And then the cosine of pi over 6. Well, how do we figure that one out? Well, how do we figure that one out? Lisa. If you know the sine, can you figure out the cosine?
You just go with the Pythagorean.
The Pythagorean theorem, right? You say, well, look, right? We know that cosine pi over 6 squared plus sine pi over 6 squared is 1, right? By the Pythagorean theorem, right? So cosine pi over 6 squared plus sine pi over 6 squared is what? Right? And the sine pi over 6 is a half. Right? So cosine squared plus sine squared is equal to 1. Right? Okay. So what does it turn out to be then? Can anyone just do it in their head? Radical 3 over 2. Okay. Right, so you work it out in your head, or however, right? This squared is equal to 1 minus a quarter, that's 3 quarters, right? So cosine pi over 6 is plus or minus the square root of that. We know it's positive again for the same reason. So we get root 3 over root 4 is 2. Right? So cosine is root 3 over 2. So this is how you figure out that the sine is a half, the cosine is root 3 over 2, and the sine is 1 over 2 for pi over 6. So,
I'm kind of confused
Yeah.
with how, I mean, I'm just trying to look at this in terms of the bigger triangle.
Yeah. So you got this big triangle, you notice that it's an equilateral triangle, right? So all the lengths are 1. And then we notice, oh look, this is, each of these lengths is a half, right? So we know the sine.
Yeah.
Yeah.
How is that caused by that side?
The cosine is this length here. Is the length of this guy here. Cosine is the length of this guy, right?
The part I don't understand. How come that's the, I mean,
Remember, so, right, we're trying to figure out the cosine and sine of pi over 6.
oh, because cosine is the x value.
Exactly.
Oh, I'm sorry. Okay, I just blanked for a second.
That's okay,
All right.
that's okay. Cosine is the x coordinate, Well, we got down here, it's this length. Okay. Anyone? Anyone else have questions? Okay, so good. Right, we got a couple more of the common guys. Right, first we figured out the cosine and sine of pi over 4. Right, now we have the cosine and sine of pi over 6. Right. The last set of easy angles is pi over 3. Pi over 3. Right. So here we take so this is pi over 3, I hope. Doesn't look like pi over 3. Something like this is pi over 3. My mom always told me that to be a math teacher, I'd have to have better artistic skills. I always said that she was wrong. So she was actually right. Okay, so this is pi over 3, and again, we're trying to figure out the x coordinate, right? The x coordinate, cosine, and the sine, right? Okay, does anyone see how we could do it? Caroline.
Well, you have a right triangle again,
Okay.
so you could make the triangle, since you know that that's, there's going to be an 90-degree angle, and then since that's pi over 3, the other angle is going to be pi over 3 as well.
No, pi over 6.
Pi over 6, sorry. And then you could use the Pythagorean theorem, because so we know that it's going to be 1, the hypotenuse. So we know that pi over 3 squared, or cosine pi over 3 squared plus sine pi over 3 squared, pi over 6 squared is equal 1.
Cosine pi over 3 squared plus sine pi over 3
Just
squared.
cosine pi over 3 squared is going to equal 1. And we have the angles. So,
Okay, you're almost there, but actually it's even easier than what you're thinking.
okay.
Okay, we just did pi over 6 guy. Here's the pi over 6 guy. Okay, and we figured out that this length was root 3 over 2, this length was a half. Right? Okay, does anyone see how, yeah, Lauren?
So it's the same distance from the y-axis that it was from the x-axis,
Yeah.
so it's just gonna be like the opposite.
Yeah, so it's gonna, you see that this triangle that we just figured out, and this triangle here, so if this is pi over 3, then this angle is pi over 6. Okay, this angle is pi over 6, this angle is pi over 3. Okay? And we have the same triangle that we had here, except flipped over. Okay, so that tells us that the x-coordinate is half, and the y-coordinate is root 3 over 2. Right? Because this guy's coordinates were root 3 over 2 comma a half. Right? When you flip it over, you see that this guy's coordinates are a half root 3 over 2. Because it's just a flip across the y-axis. I mean, it's across the x equals y line. Okay, so just by symmetry, we see that cosine of pi over 3 is a half, and sine of pi over 3 is root 3 over 2. So those guys are easy to figure. So this is sort of nice. If you memorized these in school and had no idea why they were true, now you see actually it's pretty simple to figure them out, just using some geometry and the Pythagorean theorem. Well,
So at this point, we should just know how to show or like memorize, but like show you how to find the special angles that we.
basically, yeah.
But
Like if
now-
I said, explain to me why cosine of pi over 4 is root 2 over 2.
Right.
Root 2 over 2.
Okay, but we wouldn't be expected to like know like pi over 7 or something.
Not so easy. It's not
Yeah.
so easy,
Okay.
right? I think there may be one of the homework, there's a bonus homework problem where you try to figure out something that's not, like maybe one step trickier than this. But it's not so easy to figure out these angles. So how do we figure them out? How do we figure them out? Like how do we figure out the cosine of 1? Well, I mean that to, you have to take one out. Okay, so these are the three angles for which the calculating the cosines and sines is pretty straightforward. Okay, using geometry, basically. Any questions on any of them? Okay, so let me take, now that we have those guys, okay, we can make a simple observation. Okay, so observe knowledge of cosine and sines for one angle gives us information about other angles. Okay, again by using geometry, geometry. Okay, so here's a simple one. So somebody says, okay, I would like to know the cosine and sine of this angle. Okay, so this angle is 5 pi over 4. This angle is 5 pi over 4. What's the cosine and sine? Well, you want to figure out, again, the cosine is the x-coordinate, the sine is the y-coordinate, right? Do we need to, what do we need to do? And then you say, okay, well, look, who can explain how we can get it? Can anyone tell me how to get it? Lauren?
Okay, so it's the same as it would be as pi over 4,
Okay.
except for that the x and y are going to be negative.
Yeah. Just by symmetry, you say, well, look at this thing, right? This is the same triangle here as here, right? Or you just look at, right? This is the same triangle here as here, and so you know that and this guy's x, this guy's cosine and y, cosine and sine were root 2 over 2, and so this guy's going to be negative root 2 over 2, negative root 2 over 2. Right? Right? And so this is the cosine of 5 pi over 4. This is the sine of 5 pi over 4. Okay. Another one. Suppose somebody asks you, let's say, here is 5 pi over 6. 5 pi, beta is 5 pi over 6. And somebody says, what are the cosine and sine of that guy? What are the cosine and sine of that guy? Well, what are we going to relate this back to? That's a 6. 5 pi over 6.
Well, we know that cosine is going to be negative, but sine will still be positive.
Mm-hmm.
So it's the pi over 6 was root 3 over 2,
Right.
comma 1/2.
Right.
And so in this case, it'll be negative root 3 over 2, comma 1/2.
Right. So we know, we already figured out the pi over 6 guy, right? That was root 3 over 2, comma 1/2. Right? This guy is the same, but just reflected across, it's just a reflection of that guy, right? And so we get negative root 3 over 2, comma 1/2. Right? And so this is the cosine of 5 pi over 6. This is the sine of 5 pi over 6. Right? Okay. And if I asked you for the cosine and sine of, say, 11 pi over 6, it is 11 pi over 6. Well, what would that be, Shreya?
The cosine would be positive, so it remains
The x coordinates are the same, the cosines are the same.
yeah, and then the y coordinate is negative.
That's right, so the sine is negative. Right? So we know that the cosine of 11 pi over 6 is root 3 over 2. The sine of 11 pi over 6 is negative 1/2. It's negative 1/2. Okay. Any questions? Any questions? Okay. So this is this is also something we did last time. So notice or remember, if you were here last time, remember this. If you weren't, then notice this. Oh look, if I have an angle, say like this, theta. Okay. Let me draw something. I have an angle like this, theta. Okay. Okay. And I look at pi minus theta. Okay. Pi minus theta. This guy here is minus theta. Right. This guy is minus theta. Over here is pi minus theta. This angle here is pi minus theta. Okay, those of you who were here last time, don't vote out the answer. But what's the relation between cosine of theta and cosine of pi minus theta? What's the relation between the cosines of these two angles, theta and pi minus theta?
They're kind of equal, yeah, reflected.
They are negatives of each other.
Yeah.
Yeah, right. right? One guy will be negative to the other guy, right? Because you see the x-coordinate of this guy and the x-coordinate of this guy are the same size, they're the same magnitude, but in opposite directions, right? So they're negatives of each other. What about the sines? The sine of pi minus theta, how is that related to the sine of theta? So, you got a rule. What's the relation between the sines of these two angles?
Of sine?
Yeah. Well, the sine is the y-coordinate.
Yeah, so it's sine, it would be positive, one of them would be positive and the other one would be positive.
Yes.
So they're both.
The same.
Yeah.
They're the same. They're the same. Right? Look at it. What's the relation between the y-coordinate of this guy and the y-coordinate of that guy?
They're
It's the same. Okay, so you can get from understanding the meaning of cosines and sines, you can actually get these sorts of formulas out of it. So these trigonometric identities pop out. We don't have time for it, but one that we did last time was this one. What happens if you have an angle theta, and then you add on pi to 2? Okay, so pi to 2 plus theta. What's the relation between the cosines and sines of that guy? Cosine of theta and cosine pi to 2 plus theta. Sine of theta and sine of pi to 2 plus theta. Will you get careful? No? Okay. Make a guess.
Cosine of theta equals negative pi over 2 plus theta.
Cosine theta is equal to negative this time?
Yeah.
So you're saying that the cosine of this guy is negative the cosine of this guy? The exponent of this guy? That these guys
Oh,
are
no,
negative?
no, it's not.
Lauren?
Okay, so wouldn't the sine equal the, because like it's like the same triangle.
That's
but-
right, that's right,
But,
exactly.
so the sine would equal the cosine of the other one?
Yeah, the sine of this guy, so you see the similar triangles here. The sine of this guy is the same as the cosine of this guy.
Yeah.
Right? These guys are equal. Okay. The cosine of this guy is negative the sine of that guy. So that's it for today. Okay, next time we'll do some more boring things.
Yay!